Hi guys, welcome to this session where we are going to look at the paper for NSSC Advanced Subsidiary Level. We are going to look at 2021 paper 1. Okay. Now starting with question 1, find the first three terms in ascending powers of x in the expansion of 1 minus px in brackets to the power of 6. Now I'm sure you can see that this is actually binomial expansion. Now the fact that our expression there is actually starting with 1, okay, it's 1 minus px. So if it's like that, which means the formula that we should use, of course you can also refer to the to your formula sheet. We are going to use the formula. Okay, I'll write that 1 plus ax to the power of n. The formula will be 1 plus n ax in brackets plus n in brackets n minus 1 over 2 factorial in brackets ax squared. Of course, that goes on to n minus 1, n minus 2 over 3 factorial, okay, in brackets ax cubed, of course, and so on. Okay. So in this case, if we are to compare this what we are having there with the formula, our ax is actually represented by negative px, and of course our n is 6. So what we're just going to do is to plug into this formula here. All right. So let me create space here by erasing what this formula here. Okay. All right. So we are having here 1 minus px to the power of 6 is equal to 1 plus 6 in brackets negative px plus 6 times 5 over 2 factorial in brackets negative px to the power of 2. Now remember, what they want there is just for us to have the first three terms. So the first three terms we have 1, 2, 3. So that's what we need. We don't have to go on. Now simplifying that further, okay, 1 of course remains as that, just 1, and 6 times negative px, what are we going to get? We're going to get negative 6px. All right. And then this part here, we have 6 times 5, that's 30, and then 30 divided by 2 factorial, that will give us 15, because 2 factorial is 2. All right, so we have 15. But before we actually we write that, we need to find out as to what sign we are going to have here. Is it a positive or a negative? It's very important in this case that whenever you are powering a negative, you should bear in mind that powering a negative by an even number, you get a positive. If you power a negative by an odd number, you'll get a negative. Okay, let me indicate it here. So we are having a negative to the power of an odd number. We are going to get a negative. Okay. But if we have a negative powered by an even number, we are going to get a positive. So that we should bear in mind. All right. So now in this case, we know obviously that becomes a positive. So positive, that part, and 15, what are we going to get? We are saying we are going to have 15 p squared x squared. So those are the first three terms that we need to have. All right. Now moving on to the B part, we are saying it is given that the coefficient of x squared in the expansion of this is 0. Find the non-zero value of p. So what we are looking for here is the coefficient of x squared. All right, if we are to expand 1 minus x with what we are having here. Remember, 1 minus px to the power of 6, the first three terms are those ones. And these first three terms, they include x squared, which of course is what we are looking for. We don't need to use maybe the term with x cubed. All right, so if we are going to expand this with that, what will be the coefficient of x squared? So if we can have it as 1 minus x, all right, 1 minus px to the power of 6 is going to be represented by 1 minus 6px. Okay, plus 15p squared x squared. So in this expansion here, we are only interested in the terms that multiply to give x squared. Okay, so what are those terms? In this case, I can consider 1 and that one there. That will give me x squared. What other terms will multiply out to give x squared? I can also consider negative x squared with negative 6px. That will also give me x squared. So I'll consider that one and that one. All right. We don't have to actually multiply out for all the terms, because, like for example, if we have say 1 times 1, that is not what we need. We need only the ones which gives the coefficient which gives x squared. All right. So those are the only multiplications that we have. 1 times that. So what are we going to get? If I'm going to have that, I'm going to have 15p squared x squared. And then of course, if you multiply negative x times negative 6px, we are going to have positive 6px squared. Now the coefficient of x squared then therefore will be 15p squared plus 6p. And that they are saying it is equal to 0. So we can then formulate an equation. So we are having 15p squared plus 6p is equal to 0, because the coefficient of the x squared, they are saying it is equal to 0. Now to solve that equation, what are you going to have? We are having 15p squared plus 6p is equal to 0. Now that's a quadratic equation, but of course it's actually a binomial one, because there are only two terms. So the only thing that we can do there is to factorize. We can factor out a common factor between these two terms. What do we have? We are going to have 3p as our common factor. Inside the bracket we have 5p plus 2 is equal to 0. All right, so we have 3p equal to 0, or 5p plus 2 equal to 0. But in the question they are saying find the non-zero value of p. So of course from here you see that our p is going to be equal to 0. So our p that we are interested in finding is from this equation here. If we solve that one, we are going to get p is equal to negative 2. If we divide both sides by 5, we're going to have negative 2 over 5. Okay, that will be the answer or the value of p. So now let's look at question 2. The diagram shows a parabola with a minimum point of 1, negative 3. Okay, so now that's a parabola where we have in the turning point, and of course we also have these other 2 points which are x-intercepts. So we have 2 options here. We could either use this, which is in completed square form, okay, where of course negative pq gives us actually the turning point. Or we could use y is equal to a x minus p x minus q, where p and q are our x-intercepts. So we have a choice in this case. So I'll choose to use the second equation. All right. We have to erase there to create enough space for me. So we have y is equal to a x minus 2. It becomes positive because we have a negative minus negative 2, so it becomes positive 2 there. And then x minus 4. Okay, so these are our x-intercepts that we see there. So what we then need to do there is to substitute, and another point that we are given here, which is this point here, we substitute our x value and our y value for us to be able to get our a. Okay, so we can do that. We have y, okay, our y is negative 3. Our y is negative 3. So we have negative 3 is equal to a. Our x is 1 plus 2 and 1 minus 4. Okay, so this will help us to get our a value, the value of a. Okay, so we have negative 3 is equal to a. In the first bracket we have 3, and then in the second bracket we have negative 3. So that will give us negative 9a is equal to negative 3. So what will be our a then? If we divide both sides by negative 9, we are going to get our a is equal to 1 over 3, which is 3 over 9, simplified to 1 over 3. So that is the value of a. So now with that, we can then have y is equal to, we now know our a, so we substitute our a into the first equation there. So we're going to have 1 over 3 in brackets x plus 2, another second bracket x minus 4. So we could expand that. All right, it doesn't matter, we can actually leave it in this form because they just asked us to give us the equation of the parabola. They didn't give us the form in which we need to leave it. So but we can choose, of course, to continue expanding that. So let's start by expanding these two. So if we have x times x, that will give me x squared, and then x times negative 4, that will give me negative 4x, and then 2 times x, that will give me positive 2x, then 2 times negative 4, that will be negative 8. So simplified, that gives me 1/3 in brackets x squared minus 2x minus 8. All right, so simplifying further to remove the brackets, that will be 1/3 x squared minus 2 over 3x minus 8 over 3. So that then will be our equation. Question 3 is saying solve the equation x to the power of 4 minus 81 is equal to 0. Hence solve the equation, this one here. All right. The a part there is quite simple. I'm sure you can see that we could actually take that one as a disguised quadratic equation, or we can simply just okay, yeah, let's do some substitution there. If we could say let y be equal to x to the power of 2, so that we can end up having, because from our equation x to the power of 4, we know that x to the power of 4 is the same as x squared in brackets squared. So what it means then in that case is we are going x to the power of 4 minus 81 is equal to 0. X to the power of 4, we said it's x squared in brackets squared minus 81 is equal to 0. So using the substitution of y, we are going to have y squared minus 81 equal to 0. All right. So solving this, I'm sure you can see that this is actually a difference of two squares. That's a square, that's a square. So what are we going to have here? We're going to have y minus 9, y plus 9 equal to 0. So giving me y is equal to 9 or negative 9. Okay, now with that, if I can create another space there, I could then say x squared. Remember, y is equal to x squared, so x squared is equal to 9 or x squared is equal to negative 9. But of course, we see that this is actually invalid. It's actually undefined because we can't have a square which is negative. All right, so this here is invalid. So we will carry on with x squared is equal to 9. Solving that, we will find x is equal to plus or negative 3. It's very important to not to forget positive or negative 3 there. Okay, so those are our two solutions. X is equal to positive or negative 3. All right. Now, moving on to the B part, we are saying here, hence solve the equation, that one there. Now, remember the word hence. Hence means you are actually using whatever you got in the first part to solve what we are currently having here. Okay. Now, if we are to compare this equation and that equation, we see that x is equal to square root of a minus 4. That's actually what we are having here. That which is inside the brackets is equal to x. So that's what we see there. So we are saying x is equal to square root of a minus 4. Now remember, x is equal to positive 3 or negative 3. So we are going to have here negative 3 is equal to square root of a minus 4, or positive 3 is equal to square root of a minus 4. So solving this, the first part, if we take negative 4 to this side, we are going to get 1. Okay, negative 3 plus 4, that will give me 1, is equal to square root of a. Squaring both sides, I'm going to get a here is equal to 1. All right. Now that is for this, so a is equal to 1. Now from that equation here, what are we going to have? We are going, if I'm going to take negative 4 to this side, I'm going to have 7. 3 plus 4, which is 7, is equal to square root of a. Squaring both sides, what do I get? I'm going to get a is equal to 49. 7 squared is 49. All right. To question number 4. The question is on kinematics. All right. An object is moving in a straight line, and its acceleration, a meters per square second, is given by a is equal to 6t plus 1, where t is the time in seconds after passing through O. Now the initial velocity of the object is 2 meters per second. Find an expression for the velocity of the object at time t. All right. What we are given there, we are given the expression for acceleration, and we are asked to find an expression for velocity. Again, if I'm to look at the B part of the question, they are also asking for what? For the distance, because they say how far is the object from O. So we are given acceleration, we have to find the expression for velocity. Here also we have to find the expression for displacement. So maybe what we need to know in this case is to know the relationship that exists between these three quantities. Okay, we have displacement, we have velocity, and we have acceleration. Okay, remember, for us to get velocity when we are given displacement, all right, to get velocity when you're given displacement, what is it that we are having? We are having v is equal to ds dt. So in other words, we need to differentiate displacement expression with respect to time for us to get velocity. The same also if we are to get acceleration. What is it that we need to do? We are going to differentiate the expression for velocity. All right, so in other words, acceleration in this case will be dv dt. Okay, and of course in the opposite direction we have to do integration. All right, so for me to get velocity, I will need to integrate the expression for acceleration with respect to time. So we are saying here that v is going to be equal to the integral of acceleration with respect to time. Again, to get displacement, it will be s is equal to integral of v with respect to t. So that is what we need to know here. So in this case here, we are given the expression for acceleration, and we have to find the expression for velocity. Okay, so this is where we are. We want to get the expression for velocity. So what then do we do in this case? All right, we are going to say velocity is going to be equal to the integral of acceleration with respect to time. All right, so what is our acceleration? Our acceleration is given as 6t plus 1. All right, so if we integrate that, we are going to get integrate this part here. That will be 3t squared plus t. But of course, remember this is integration, so we have to add the constant of integration. All right, now we are given the condition. If you read through the statement that we are given there, we are told that the initial velocity of the object is 2 meters per second. Initial, it means time is equal to 0. That's what it means. Okay, it means t is equal to 0, and of course velocity at that moment is 2 meters per second. In other words, what it means is that this object, we started observing this object when it was already moving, it was already in motion. Okay, so initially when time was 0, velocity was 2 meters per second. So that's what we are going to have. We substitute this in there for us to be able to get the constant of integration there. All right, so we have 2 is equal to 3 in brackets 0 squared plus 0 plus c, which of course will give us c is equal to what? To 2. All right, so it means the expression for velocity then becomes, because that was actually a general expression that we are having there, but for us to get a specific expression, knowing of course the constant of integration, we need to substitute this. You are not going to be given this information here, but it is always going to be in the statement that they give you, like where they are saying the initial velocity. It means initially, meaning to say that time is equal to 0 at that moment, and of course they are telling us that the velocity at that moment was equal to 2. So that's what we are having there. We substituted and we got our constant of integration. So with that, it means then our expression for velocity then is going to be 3t squared plus t plus 2. This gives our expression for velocity. All right. Now in the B part of the question, we are asked to find, they're saying how far is the object from O after 3 seconds. So that means we are looking at the distance after 3 seconds. So for us to be able to get the distance, we need then to find, first of all, the expression of displacement. So this is where we are. We now have the expression for velocity. So for us to get the expression for displacement, we just need to integrate. So this is what we are going to have. All right. So we are going to say S is equal to the integral of velocity with respect to time. Okay, so the integral of velocity, we have 3t squared plus t plus 2. That's with respect to time. So the expression, if we integrate that, we are going to get t cubed there on that part, and the second part there is going to be half of t squared plus 2t plus c. All right, but how then do we get the constant of integration here? We remember that what we know is that initially, that's when time is equal to 0. All right, the displacement is also equal to 0. So if we substitute that, where t is equal to 0, and of course displacement equal to what? Equal to 0. We are going to have here 0 is equal to, substituting there, 0 cubed plus half of 0 squared plus 2 multiplied by 0 c plus c. So in other words, our c is going to be equal to 0. So the expression then therefore is going to be what? S is equal to t cubed plus half t squared plus 2t. All right, now remember that t is equal to 3 in this case. So if we substitute that, we should be able to get the distance after a time equal to 3 seconds. So we're going to have S is equal to 3 to the power of 3 plus half of 3 squared plus 2 in brackets what? 3. So what we get, we have 9 plus that's 27. That's 27 here. 3 cubed 27 plus 3 squared times half, that will give you 9 over 2 plus 6. All right, so we have 27 plus 6, that's 33. 33 plus 4.5, which is 37.5 meters. So that's the distance after 3 seconds of moving. Okay. Or what we could have simply done here, instead of actually getting to have the constant of integration, we could have taken this as definite integration, where the limits are from 0 to 3. We just substitute that, then we integrate, of course, and then we substitute our limits. Okay, but either way, that should give you the answer. All right, looking at question 5, they're saying solve the equation 2 over cos theta is equal to 7 minus 3 cos theta for theta is between 0 to 360. Okay, now obviously you know that an equation that has got a fraction, the first thing that you need to do is to get rid of that fraction. So in other words, in this case here, it would be better if we can maybe do cross multiplication. So we make this one over 1. Right, so we have 2 over cos theta is equal to 7 minus 3 cos theta. That's over 1. So to get rid of the fraction there, we cross multiply. So in other words, we are doing cross multiply like that. All right, so what we have, 2 times, okay, let's have cos theta multiplied by that. So cos theta times 7, that will be 7 cos theta minus cos theta multiplied by negative 3 cos theta. That will give us negative 3 cos squared theta. That is equal to 2 times 1, which gives us what? 2. All right, so if I'm to take all the terms that are on the left hand side to the right hand side, what am I going to get? I'm going to get 0 is equal to 3 cos squared theta. It's negative this side, so the other side becomes positive. Okay, and this one, if it goes to the other side, it becomes negative 7 cos theta. All right, of course, plus 2. Right, so we have that equation, which of course you can see that that's a disguised quadratic equation, which is in trigonometric form. Okay, so if we can make the substitution, let y be equal to cos theta. All right, so we're going to have 0 is equal to 3y squared minus 7y plus 2. So we have 3y squared. Okay, I'm just want to flip that equation and have it like this. Now, what is the method that we could use there? The best method would be to factorize, because it doesn't take much space. As you can see, the space that we are having here is not much. So what do I have here? I have 3 times 2. I'm going to get 6. So what are the factors of 6, which will add up to give negative 7? So we can talk here of negative 1, negative 6. So negative 1 times negative 6, I'll get 6. Negative 1 plus negative 6, I'll get negative 7. So which, of course, what I need. So I'm going to say negative 1 minus 1 and y minus 6. Okay, but since the coefficient of y squared here is 3, we're going to divide here by 3 by 3. So I'm going to have over 3 there, over 3. So my equation is negative 1 over 3 y minus 2. So if I'm to solve that, I'm going to have y is equal to 1/3 or 2. But remember, cos theta is what is representing y. Y is representing cos theta. So we have cos theta is equal to 1/3. Of course, we can solve this one here. But talking of cos theta equal to 2, that's invalid. Okay, so if I can create more space here, I'm going to solve the equation cos theta is equal to 1/3. Right. So remember, the first thing that we need to do here when we have our trigonometric equation, I need to get my basic angle. So theta is equal to inverse of cos of 1/3, which is going to give me, I will have to use a calculator there. So we have 70.53. Okay, it's 70.53 degrees. Okay, the basic angle is always better to give it into the 2 decimal places, since the final answer will be to 1 decimal place. Okay, so to 2 decimal places, that's what we are having here, 70.53. That's our basic angle. Now, but remember, cos theta is positive. In which quadrants? That's in the first quadrant and the fourth quadrant. Okay, according to if we have our cast diagram like this here, remember our angle is theta is equal to the basic angle, of course, which in this case is also theta, and that's in the first quadrant. And then in the fourth quadrant there we have theta is equal to 360 minus theta. Okay, so what will be our solution in that case? We have 70.5 degrees. That's for the first quadrant. Now in the fourth quadrant, we are going to have 360 minus 70.53, which gives me 239. That will give me 239.5 degrees. Okay, so those are the 2 solutions that we are having in this range for that equation. All right, so moving on to the second part of the question. This is a trigonometric identity. Remember what we need to do with the trigonometric identity. You need to start from one side, simplify it to go to the other side. Now in this case here, I see I have two terms here, which on the right hand side we only have one term, so it's better to simplify from this side to that side. So with this one here, the only thing that I can do is to maybe convert the tan squared. Okay, let me write it. Tan x minus sine squared x. I'm starting with the left hand side. Okay. Now remember, tan is sine squared x over cos squared x. All right. Minus sine squared x as a fraction, I'll just write is sine squared x over 1. So I'm going to write that as a single fraction. Why am I doing that? Is because I see that this one here is a single term. So I should make this, write this as a single fraction. So with that, what then am I going to have? Remember, when you're dealing with fractions, if you're having a over b minus c over d, all you need to do there is to multiply b times d. You get your common denominator, which is what? bd. All right. Now, then you cross multiply a times d. You're cross multiplying through the sign, not the equal sign, right? So it's a times d, and then this times that. So we are having AD minus BC. That is what we are having here. So that's what we need to do here. So for you to deal with this, your algebraic fractions should be good. So in this case, I'm saying here cos squared x times 1. What am I going to get? I'm going to get cos, I'm going to get cos squared x. All right. And then multiply this one times that. That will give me sine squared x minus this times that. What am I going to have? I'm going to have sine squared x cos squared x. All right. Now I have a single fraction. So what do I need to do in this case? Looking at where I'm going, remember what I need to simplify to is tan squared x sine squared x. So in this case here, it looks like I need to factorize my sine squared x. Okay, so if I factorize sine squared x, I'm going to have inside the bracket 1 minus cos squared x all over cos squared x. All right. Now, remember sine squared x over cos squared x, that will give me tan squared x. And the bracket there will give me sine squared x. So I can have it as sine squared x over cos squared x. And of course, inside the bracket I have 1 minus cos squared x. So what do I have? The fraction here gives me tan squared x. Okay, the bracket gives me sine squared x. So I've managed to prove the identity. I've moved from the left hand side to the right hand side. Okay. Now looking at question 6, relative to an origin O, the position vectors of points A and B are given by OA is 336, OB is 152. Now the point P lies on AB such that AP is equal to 3 over 2 AB. Find the coordinates of P. Okay. Now for us to find the coordinates of P, obviously we need to find the position vector of OP. So the best would be, remember this is a displacement vector. If we could write this displacement vector as position vector of A and P, the same also for AB, then it will be easy for us to get OP, and then from there we can get the coordinates of P. All right, so what then do? We could say our AP which is this part here, we could write it as what? It's OP minus OA. That's what it is. That's our AP. That is equal to 3 over 2 AB. Now AB, in terms of position vectors, that would be OB minus OA. Okay, so of which this one here, we can easily find it, OB minus OA. We can easily get that one there. So we make our OP the subject of the formula. So we take this one to the other side. So I'm going to have here OP is equal to 3 over 2 OB, all right, which is 152 minus OA, which is 336, all right, plus OA, which is 336. So what I'm going to have there, I'm having here my scalar 3 over 2, 1 minus 3, which is negative 2, 5 minus 3, that's 2, 2 minus 6, that's negative 4. Okay, plus 336. All right, now I'm going to multiply out this scalar times our AB, the simplified AB. So what am I going to have here? I'm going to have 3 over 2 times negative 2, that will give me negative 3. 3 over 2 times 2, that will give me 3. 3 over 2 times negative 4, that will give me negative 6. Okay, so that part there is simplified to that, plus 336. All right, that is equal to negative 3 plus 3, that's 0, and then 3 plus 3, that will give me 6, and then negative 6 plus 6, that will give me 0. Okay, so meaning to say that our OP is then equal to 0, 6, 0. So therefore the coordinates of P will be 0, 6, 0. All right, so that's what we just did there, quite easy. So what was the strategy? This relationship that we are given here, we have these two displacement vectors. So we wrote this displacement vector in terms of the position vectors of P and A. So AP is equal to OP minus OA. That's what we did. So that's my AP there. Equal to 3 over 2 of AB. AB is OB minus OA. That's what we have. Of which OB I'm given, that's 152. That's what I'm having here. Minus OB minus OA, which is 336. That's what we have here. So if we simplify what is inside the brackets, we're going to get this. 1 minus 3, negative 2. 5 minus 3, 2. 2 minus 6, negative 4. So that's what I'm having inside the bracket. So with that scalar outside, of course, plus this, because we had to take this one here to the other side. So it became positive. So that's what I'm actually having. So the first thing for me to simplify this, I need to multiply this scalar times the vector, of course, plus that. We should get that. Okay, so when we get that, gives me my OP. So OP, straight away it gives us the coordinates of P. That's what we are having there. All right, now moving on to the second part of the question, which is B. Show that AP is perpendicular to OB. Now, vectors that are perpendicular to each other, what is it that we know about them? We expect the scalar product of AP and OB, to be equal to 0. That's what we need to do. So we have our AP, and OB, of course, is given. So what is our AP in this case? Our AP, which we got that already. Of course, that is actually our AP here. We don't have our AP because we didn't have OP. So we can now find AP. All right, we can now find AP. AP in terms of position vectors, that becomes OP minus OA. All right, so it's OP minus OA. So OP, it's 0, 6, 0 minus OA. What is our OA? Our OA is given as 336. Okay, that's 3, 3, 3, 6. So if we simplify that, 0 minus 3, we get negative 3. 6 minus 3, that's 3. And 0 minus 6, that will give me negative 6. So that's AP. That's my AP. Now, AP, the dot product of AP and OB, what do we have? AP, we are saying is negative 3, 3, negative 6. Multiplied by OB, we also given that one. OB is 152. Okay, 152. So the dot product of that, what we have? Negative 3 times 1, we get negative 3. Plus 3 times 5 plus negative 6 times 2. So what do we have here? That's negative 3 plus 15 minus 12. So that will give me 0. So that therefore shows that AP and OB are perpendicular to each other. Okay, so that's what we are having there. Now coming to question 7. The diagram shows a metal plate made by fixing together two pieces, OBC, that's OBC here. All right, the shaded one, and the ODEA, ODEA, so the unshaded part there. Okay, now these two pieces fixed together. So they are saying the piece OBC is a minor sector of a circle with center O and radius 2r. Of course, from here, that's r, there r, so that becomes 2r. Now, the piece ODEA is a major sector of a circle with center O and radius r. Okay, it's major because there is the minor one. This one here, that's the minor one. So the major one is this one here. So what are we saying here? They're saying the piece ODEA is a major sector of a circle with center O and radius r. Angle AOD is pi radians. Okay, so that's the angle there. So what is the first part of the question? 7a, simplifying your answer, find in terms of alpha, pi, and r the perimeter of the metal plate. Now, when we are talking about perimeter for that metal plate, obviously we are referring to that part there in blue, and of course that part there in green. All right, so let's start by getting the length of the blue part there, okay, which is the perimeter for that. Obviously, we are not going to include this because that's actually the inside. Remember, perimeter, we are referring to the distance right around the shape. That's the perimeter. We can't obviously include these two parts here. They are out. Okay, so if I'm to find this part first, what do I need to do? Obviously, I need to have the angle, this angle here. How do I get that angle? It's going to be 2 pi, okay, because that's a full revolution, that's 2 pi minus alpha. So angle O is gonna be 2 pi minus alpha. Okay, so that is the angle that we are having. So obviously that's the angle that we have to use. So for the length of AED, which is the part which is in blue there, remember the formula is r theta, r being the radius, so it's obviously r, and then theta the angle. I'm going to use 2 pi minus alpha. Okay, so simplified is 2 pi r minus r alpha. So that is the perimeter which is in blue, or the length, that part there, AED. So that's what I'm having here. Now looking at the part which is in green, obviously this AB, that's R, and DC is also R. So all we need to do for now is to find the length of the arc, which is this one here. All right, again I will call it LBC. Okay, LBC. What do I have in that case? I'm going to have R. Okay, remember the formula is r theta. Okay, but what is our r? Our r is 2r, the radius, multiplied by theta, which is alpha. Okay, so that's our BC. Now the length of the whole part ABC, A, B, C, D. Okay, what is it going to be? It's going to be r plus 2r alpha plus r, which of course simplifies to 2r plus 2r alpha. Okay, so the perimeter that we need, we are going to add these two, this one here in blue plus the one in green. All right, so we have 2 pi r minus r alpha plus 2r plus 2r alpha. Okay, of course that simplifies to these two here can be simplified. Okay, so that will give me r alpha. So we have 2 pi r plus 2r plus r alpha. Okay, so that's what we are having here. That's our perimeter. Now, of course, going on to where they are saying in case where r, the radius is 5 centimeters and alpha is 0.8, that's in radians. Okay, find the area of the metal plate. Okay, so the area of the metal plate, obviously, so in this case, for us to get the area of this metal plate, it's very important here to maybe consider the fact that, okay, if I may complete my circle here so that we can have a full circle. So my area for the metal plate will be that, okay, plus this part here, the remaining part. It's not a matter of just getting the area of this plus the area of that, because then you actually remember this part is overlapping. Okay, so if you are to choose to get this area here, because this area is also included, so we can make it as a full circle, all right, plus this area. But the question is, how do we get this area here? Obviously that's quite easy. We are going to get the area of the full circle, full sector, right, this one here, OBC minus OAD. Okay, so let's start by getting the easy one, the area of the circle. All right, FC, full circle. All right, so which is pi r squared. What pi and my radius is given as 5 squared, so that will give me 25 pi. So that's what I'm having here. Now I'll need to find the area of the small sector here, which is AOD. Area of AOD. It's always important here to get to understand the whole picture, but that whole picture you divide it into small pieces. Okay, so we want the area of this one here. What are we having? It's, remember, it's half. The formula is half r squared theta, which in this case we have half. Our radius is 5. Of course, squared. And then our theta is 0.8. Okay. So we are talking here of 25 multiplied by 0.5, which is half. Okay, multiplied by 0.8. That will give us what? 10. That's the area of the small sector. And then the area of the bigger sector, all right? The area of the bigger sector, which is OBC. That whole sector here, that's the area that we want, the whole shaded area, which again, the formula, it's half. Okay, but what is our radius this time around is 2r, so we are having 2 times 5, which is what? 10. So that is squared multiplied by 0.8. Still the angle remains the same. All right, so we are having 0.5 multiplied by 10 squared is 100 multiplied by 0.8. Okay, so that will give us what? 40. Okay, so that's what we are having. So now the area that we need to find is this that I'm actually shading in red. So I'll say it's area of A, B, C, D. It's gonna be 40 minus 10, which gives me 30. All right, so that 30, I'm going to add it to the full circle. So it's the area of the full circle plus that. So the area of the plate, now at the end, area of the plate is going to be 25 pi plus 30. Of course, if we simplify that, 25 pi plus 30, that will give me 108.5398. Okay, so the final answer will be to 3 significant figures. That will be 109 unit squared. Of course, the units here are centimeters, so it's supposed to be centimeters squared. All right, so that's what we are having here. Okay, now looking at question 8. Each year a company donates money towards the prize giving ceremony held at a school. The company increases the amount of money donated each year by 10% of the amount donated in the preceding year. And the donation in 2010 was 1,000 Namibian dollars. Now find the total amount of money donated to the school during the years 2010 to 2018 inclusive. Correct to the nearest 10 Namibian dollars. All right. Now, it's important here to actually be able to identify as to what type of sequence we are having here. I'm sure you can see that because we are actually saying 10% of each of the preceding year. So it's actually the amount that is actually donated is increasing by 10%. So that should actually be a GP. We are actually having a GP sequence here, a geometric progression. All right. Now, if we are to find the total amount of money donated It means we are looking here of at what, at Sn equal to a in brackets r to the power of n minus 1 over r minus 1. All right, so because we are looking for the total amount, so that's the sum of the first n terms. Now obviously we need to be able to find out what is our r, our n, okay, our r and our a. Of course, starting with a, our a is given, it's 1000. That is the amount that was donated initially in 2010. All right, and our r, it's easy because what we just need to do is to say 100%, okay, because that's an increase, so we can just add that to get what, 110%, which of course simplified to decimal form, that should be 1.1. So that's our r, okay, our common ratio. All right, the other way would be to find our we already have T1, so we can find T2, and then of course to get the common ratio we would say T2 divided by T1. We'll still come back to that. All right, and then our n, what would be our n? We are starting from 2010 all the way to 2018. They are saying inclusive. Now it's very important here to realize that if we are talking about, let's say, suppose maybe we say from 2010 to 2011, 2012. Let's suppose we had said from 2010 to 2012 inclusive. How many years are they going to be? What we need to do here is that we need to subtract this minus that, but then we need to add, because how many years are these ones? If we are to add, to have the years 2010, 2011, 2012, so there are 3 years. So it's not a matter of just saying 2012 minus 2010, otherwise we just get 2, which is actually wrong. Okay, so whenever they say inclusive, you need to say 2012 minus 2010 plus 1, so that we can have, of course, 3 years. So in this case here, we're starting from 2010 to 2018 inclusive. So meaning to say that my n is then going to be what? 2018 minus 2010 plus 1. Why? Because we're saying inclusive. So that gives me 9. All right. So then the total amount, then using that formula there, we are going to say S9. It's going to be 1000 in brackets 1.1 to the power of 9 minus 1 all over 1.1 minus 1. What do we get there? If we are to use our calculator, plug that into the calculator, we should get 13,579.47691, of course, and so on. All right, but we need to round off. Since this is actually money, we can round off to 2 decimal places. So we are going to have 13,579.48. Okay, that's to 2 decimal places. All right. Now looking at the B part, we are asked here we are told here that another company also decides to donate 1,000 in 2010. And this company, however, increases the donation each year by a constant amount of A. So it means we are adding. They are actually adding A to 1,000. So in 2010 is 1,000. In 2011 it's going to be 1,000 plus A. All right. And in 2012 it's going to be 1,000 plus A plus A. All right, which is 1,000 plus 2A. All right. So meaning to say that this one here is we are having a common difference. So the type of sequence that we are having here is an arithmetic progression sequence. All right, where we have a common difference. In this case, our common difference is given as A. All right, and of course, as we have been told, our A is 1,000 Okay, that was the first amount that was donated. All right, still it is still from 2010 to 2012 inclusive, so the same period. So the number of years here, it is still going to be 9. All right, but since it's actually an AP, remember the sum of the first n terms for AP is going to be Sn is equal to n over 2 in brackets 2a plus d in brackets n minus 1, again square brackets there. Okay. All right, so what they are saying here, they're saying find the value of A for which the total donation of the years would be the same for both companies. So we have to use the same amount, that the amount that we got in the first part there, which is we had, so that's what we are going to have here, this amount here. It's better to use the amount which is not actually the value here, which is not rounded off, so we use it here, and then we substitute, of course, what we have, but our D is A, so that's what we need to find out, what will be the value. Okay, so remember my SN is 13,579.47691. That is equal to 9 over 2 in brackets 2 times 1,000. All right, plus my D is A, okay, times 9 minus 1, which is what? 8. So simplified, that should be 9 over 2 in brackets there we have 2,000 plus 8a. Of course, this side we still have 13,579.47691. All right, so we have to solve this equation here to solve for A, which is the value. We want to find the value of A. So what we need to do first of all here, 9 over 2 is 4.5, so we can divide both sides by 4.5. So having 13,579.47691, okay, divided by 4.5. What are we getting? We are going to get 3,017.661536 is equal to 2,000 plus 8a. So this 2,000, if it comes this side, what are you going to have? We subtract that. We are going to have 1,017, of course, 0.661536 is equal to 8a. All right, divide both sides by 8. If you divide both sides by 8, we are going to get 127.2076 and so on. Of course, rounded off, since this is actually money, if we round off to 2 decimal places, we are going to have 127.21. So that's in Namibian dollars. Okay, so that's what we are actually having there. All right, now looking at question 9, the diagram shows part of the curve y is equal to 9 minus x squared, intersecting the y-axis at 0.9 and the x-axis at 3. Okay, so that's what we're actually having there. All right, the y-axis at 0.9 and the x-axis at 30. So that's the curve. That's the curve that we're having, and of course we have that shaded area. So what is it that they want us to do on part A? We are supposed to show, they're saying showing all the necessary working, find the area of the shaded region. So to get this area here, we need to obviously to integrate. Okay, so this is actually what we are going to have. We are going to have A is equal to A, okay, x is equal to a, x is equal to b, y dx. So that's what we need to integrate there. Why is it like that? Because if we are to, maybe let me get just a template part there. Now that looks like obviously a rectangle, okay, and that will remain, that will be the same throughout. So with that, I'm sure you can see that this is dx and that is y. So that is what we are having here. The area for this will be y dx. If we multiply that, we are going to get a is equal to y dx, because that's a rectangle. All right, so if we are having many of these rectangles there, which we make in that area, in that shaded area, for us to get the total area, we need to integrate them. In other words, bring them together. So that's what we're actually doing, starting from x is equal to a, which is our a here in this case, which is 0, and our b being what, 3. So to get the area there, we are going to say the limits from 0 to 3. Our y, what is our y? Our y is equal to 9 minus x squared. That's the function that we are having here, 9 minus x squared dx. So we need to integrate. We need to integrate that. So that's definite integration. So we're going to have 9x. The integral of negative x squared will be x cubed over 3. Now, since this is definite integration, we just need to, we don't need to put a constant of integration, but of course we need to substitute the limits there. The substitute of the upper limit, that will be 9 multiplied by 3 minus 3 cubed over 3. That's in the first bracket, minus, of course, 9 times 0 minus 0 cubed over 3. All right, so what are we going to get here? If we simplify what is in the first bracket there, we have 9 times 3 is 27 minus 3 cubed is 27 divided by 3, that will give me 9. All right, of course this here is just 0. All right, so what do I have? 27 minus 9, I'll get 18 units. Now that should be unit squared, because we are looking for that area here. Okay, now if we are now going to talk about finding the volume generated in terms of pi when the shaded region is rotated through 360 degrees about the y-axis. Now when we have this, especially the volume of revolution, we just need to write down the formula and be able to know what we need. Like in this case here, we are asked to find the volume that is generated if this area here, the shaded area that we got, if it is rotated around the y-axis. Okay, now the formula for volume generated around the y-axis, it is pi integral of the limit from the lower limit will be y is equal to a, y is equal to b, x squared dy. That is actually the formula. So of course we know, since it's now volume, that should be pi. All right, our limits in this case, it should be the limits of y. So we are starting from 0 to 9. Okay, and the x squared, where do we get the x squared? We can make, from the equation that we are given there, we can make x squared the subject of the formula, and so we substitute there. So that's quite easy. So what then do we have? We are going to have volume generated around the y-axis. We have pi integral from 0 to 9, okay, x squared dy. But what is x squared? Remember, we have y is equal to 9 minus x squared. We can make x squared the subject of the formula here. I've just brought this to this side, and then of course y to that side. So I'm going to have x squared is equal to 9 minus y. So going back to our formula, which is this one here, I'm going to have pi integral of from 0 to 9, 9 minus y. Okay, so that's what we are integrating. Our limits are from 0 to 9. What do I get if I integrate that? I'm going to get 9y minus y squared over 2. Okay, of course, we should not forget the pi from 0 to 9. Now, substituting the limits, we have pi. Okay, for the upper limit, we have 9 times 9 minus 9 squared over what? 2. That's what we have there. That's for the upper limit, minus for the lower limit, of course, 9 times 0 is 0, minus 0 squared is 0. Okay, so all we have there is going to be pi. For the first bracket, we have 9 times 9, which is 81, minus 9 squared, which is 81 divided by what? By 2. What are we going to get? We're going to get 40.5. All right. So simplifying what is inside the bracket, we have 40.5. 81 minus 40.5, we are going to get 40.5 pi. Okay, so that is our answer in pi form, of course, which can also be expressed in decimal form. What are we going to have? 40.5 times pi. We are going to get 127.234 and so on, but to 3 significant figures, that will be 127 unit cubed, because that is volume. All right, now looking at question 10, the line y is equal to mx plus 4, where m is a constant, does not intersect the curve y is equal to x squared minus 2x plus 20. Find the range of values of m. So I'm sure you can see that the question here is on nature of roots. All right. So what we are having here, we are having a curve and a straight line, which apparently they are saying here that they do not intersect. So that's what we're having here. A parabola and a straight line, which are not intersecting. So what situation do we have for our discriminant? Remember, nature of roots is mainly to do with discriminant. Okay, our discriminant, we expect our discriminant to be b squared minus 4ac being less than 0. So that's what we want to have. But the first thing that we need to do, obviously, is to create a quadratic equation, all right, from these two functions here. Since they are not intersecting, of course, we still have to say x squared minus 2x plus 20 is equal to mx plus 4. So we need to create a standard quadratic equation from there. And now if we bring all these terms from the right hand side to the left hand side, what are we going to have? We are going to have x squared minus 2x minus mx plus 16 is equal to 0. All right, so we then can be able to extract our a, our b, our c from this equation here. What is our a? Our a is equal to 1. Our b is equal to negative 2 minus m. B is specifically the coefficient of x, and then our coefficient of x squared is our a. All right, and then our c is the constant one. What is our constant here? It's 16. All right, so with that we can then substitute ABC into this inequality there. Okay, so we're going to have negative 2 minus m squared minus 4a is 1 times c, which is what, 16. That should be less than 0. Now expanding this part here, what are you going to have? Negative 2 squared, we have 4. Then negative 2 times negative m, that's positive 2m times 2, we're going to get 4m. And then negative m squared, we are going to get positive m squared. Of course, negative 4 times 16, we are going to get negative 64, less than 0. Now, rewriting this, what are you going to have? We are going to have m squared plus 4m, all right? And then 4 minus 64, that will give me negative 60, less than 0. All right, so that's the 0 there. So this is a quadratic inequality, which if we are to solve it, what we need to do there will be to take it, first of all, as a quadratic equation. Why so? Because we want to find the x-intercepts, all right? Because we need to have something like that. So we need to be able to get these x-intercepts. And for those x-intercepts, y is equal to 0, because that's our x-axis here. That's our x-axis. So along the x-axis, y is equal to 0. So we would have to take that one as equal to 0. Okay, now less than or greater than, those are regions. Above the x-axis, that's greater than 0. And below the x-axis, we have less than 0. Okay, so the region that we want is for less than 0, which is actually below the x-axis. So we want to find the values of x for which this function here is below the x-axis. So now if we are to look at this, I'm sure you can see that we can factorize. All right, we have negative 60. Now what are the factors of negative 60? That gives us 4. That should be 10 and negative 6. All right, 10 plus negative 6 will get 4. 10 times negative 6 will get negative 60. So to factorize that, we are going to have m plus 10, m minus 6 equal to 0. So we are going to get our m is equal to negative 10 or 6. All right, now looking at the graph that we are having here, so if, okay, let me draw another one. Obviously my graph is cupping upwards. Why? Because the coefficient of m squared is positive, so the graph should be looking upwards like that. So this here should be negative 10, that should be 6. Of course, that's our x-axis. So where is that graph? Below the x-axis. This less than 0 means below the x-axis. So this is the part. These are the values of x, starting from negative 10 to 6. For those values of x, we are having our x, our graph below the x-axis. So we have m less than 6, but greater than what? Negative 10. That is actually the range of values of m, for which that curve, the curve of this function here, and that's the straight line of that function are not intersecting. That's what we actually asked to look for here. Find the range of values of m. Okay, so that's what we are having. All right, now moving on to b, they are saying explain why the equation 3x squared minus kx minus k squared is equal to 0, where k is a non-zero constant, always has 2 real roots. Now, what it basically means is that if we are having 2 real roots, remember for the discriminant, the topic of nature of roots is basically about the discriminant that we can extract from a quadratic equation. So there is the quadratic equation that we are having. All right. So the discriminant that we can extract from this equation, it should be greater than 0 because we're having two distinct or two real roots. So which means our discriminant should be greater than 0. All right. But to explain there, we are saying there is our discriminant, which is equal to what? B squared minus 4AC. Now, what is our B from there? Our B is negative K. So we can have negative K squared minus 4. Our A is 3, the coefficient of x squared, that's 3. So we have 3 there. And then our C is what? Is negative K squared. So that's what we are having. Now, if we simplify that, negative K squared, we get K squared. All right. And then 3 times negative K squared, we are going to get negative 3K squared times negative 4. We get positive 12K squared. All right. Now, we need to explain that this here is greater than 0 for us to have two real roots. Now, remember, this is a square. A square is always positive for all the values of k. The same also for this part here. So 12 times a positive, we'll get a positive plus this positive. Now, but remember, k squared plus 12k squared, we are going to get what? 13k squared. So we have to deal with this one here. Now, so what are we saying? We are saying for all the values of k, whether positive or negative, k squared is always, how do I write this? This is a notation for all the values of k. We are saying k squared is always going to be greater than what? 0. Therefore, 13k squared is also greater than 0. Which means that our discriminant is actually greater than 0. All right. Therefore, we have two real roots. Okay. We have two real roots. So that's actually the explanation that we have to give there. All right. Now, looking at question 11, the equation of a curve is y is equal to x squared plus 16 over x. All right. Find the coordinates of the stationary point. That's what we need to do there on A. For us to get the stationary points, what we need to do first of all is to differentiate this. When we differentiate this, then we equate to 0, because remember, at stationary points, when we are having a curve like that, stationary points, the tangent is actually parallel to the x-axis. In other words, the gradient is equal to 0. Okay. So let's have it. Let's see if I could represent the function in terms of f. F of x is equal to x squared. This part here, I need to first of all rewrite it in standard form. Remember, the standard form, when you are differentiating a simple function, it should be a x to the power of n. All right. So each term should be like that. So this one here is okay because we know that our a is 1 and then our n is 2. But for this one here, we need to rewrite it. So it's going to be plus 16x to the power of negative 1. Right, then we differentiate that. What are we going to have? The derivative of x squared is going to be 2x. And then the derivative of 16x to the power of negative 1. That will give me negative 16x to the power of negative 2. Okay, which of course, again, if I simplify that, because remember, this is actually not in simplified form because it has got a negative power. So it should be 16 over x squared. So we convert into positive power. All right, so that's the derivative that we are having here, f of f. So at the stationary points, what we are saying that the derivative is equal to 0. So we are going to equate that derivative to 0. All right. So that's negative 16 over x squared is equal to 0. So we need to solve this equation. The best would be maybe to take negative 16x squared to the other side. So I'm going to get positive 16 over x squared. And of course, cross multiply. All right. This one, if I can make it to be over 1. So what do I get? 2x times x squared. I'm going to get 2x cubed is equal to 1 times 16. That will give me 16. So then divide both sides by 2. I'm going to get x cubed is equal to 16 divided by 2 is what? It's 8. So the cube root of x cubed is x, and then the cube root of 8 is 2. So that's what we are having here. So our x, the x coordinate of the stationary point is 2. So then how do we get the y coordinate? We can then substitute the x value into the original equation where we have y is equal to, right, x squared plus 16 over x. So I'm going to have 2 to the power of 2 plus 16 over 2. So that will be 4 plus 8, which is 12. So the stationary point that we need here is 2, 12. Now then, moving on to the B part of the question, where they are saying find the equation of the normal to the curve at the point. All right. Remember the relationship that exists between the tangent. So if this here is my tangent at that point there, my normal line will be this one here. The two should be actually perpendicular. So what I need to do there is to get the equation of the tangent. I mean the gradient of the tangent. Now that gradient of the tangent, since they are perpendicular to each other, the tangent and the normal, the two gradients should be reciprocals of each other, but of course with different signs. So let me get the gradient of the tangent first. How do I do that? I will just need to substitute this x coordinate here in my derivative, which I got here, all right, in the first part. So I'm going to have to say gradient of the tangent is going to be 2, substitute 4, all right, minus 16 over 4 squared. So what do I get? That will be 8 minus 16 over 16, which gives me 1, which gives me 7. Okay, so 8 minus 1, which is 7. So therefore, the gradient of the normal line, it should be the reciprocal of 7, which is 1 over 7. But of course, it should have different signs. The two should have different signs. So this one should be negative. So we have negative 1 over 7. All right. So the equation of a straight line, remember the normal is a straight line. So this is how we get the equation of a straight line. It's y minus y naught equal to the gradient in brackets x minus x naught. Okay, so that will be the gradient of the straight line. X naught and y naught, those are the coordinates of the point through which the line passes through. So what are we saying here? We can have y minus y naught. The y coordinate is given there is 20. So we have y minus 20 is equal to, the gradient is negative 1 over 7. And in brackets, we have x minus, the x coordinate is 4. All right, so that's what we are having here. Simplifying that, I'm going to have y minus 20 equal to negative 1 over 7x plus 4 over 7. So, of course, rewriting that, I'm going to have negative y is equal to negative 1 over 7x plus 4 over 7 plus 20. Okay, so using a calculator to simplify this part here, we have 4 over 7 plus 20. So that will give us y is equal to negative 1 over 7 x plus 144 over 7. Okay, so that is our equation here. That's the equation of the normal. All right. Now looking at question 12, which is the last question of the paper, the function f is such that f of x is equal to square root of 2x plus 2 for x is greater than or equal to k, where k is a constant. Find the least possible value of k. Now, there is a function that we are having, and that should be the domain of the function. So when they are saying find the least possible value of k, we are to try and find the possible domain of such a function here. All right. So remember, what we need to know is that we cannot have the square root of a negative. So that which is inside the square root sign should always be greater than or equal to 0. Of course, it's possible to have square root of a 0. So we have 2x plus 2. That should be greater than or equal to 0. So if we solve for x in this case, we're going to have 2x greater than or equal to 2 going the other side. It becomes negative 2. We are going, and then we divide both sides by 2. We then have x is greater than or equal to negative 1. All right. So then if we compare this, which we got, and that, it means that k is equal to negative 1. So that is the least possible value of what? Of k. So k is equal to negative 1. That is what we are having. All right. So the domain of that function is x is greater than or equal to negative 1. So, but if we have, say, for example, x is equal to negative 2, and we substitute there, 2 times negative 2, we get negative 4 plus 2, that's negative 2. So we are going to have a square root of a negative, and that is what we don't want. Okay, the square root should always be 4, greater than or equal to 0. All right, so that's how we get our k. Now moving on to B part. For the value of k found in part A, all right, find an expression of the inverse function and state its domain. All right, so let's see how we can get the inverse function. Remember, we have f of x is equal to square root of 2x plus 2. So to get the domain, can we use y? So we have y is equal to square root of 2x plus 2. The first thing that we need to do there is to interchange the variables. So y becomes x and x becomes y. So we're going to have x here is equal to square root of 2y plus 2. All right. So what we now need to do is to make y the subject of the formula. So the first thing that we need to do here is to square both sides. If we square both sides, the left-hand side becomes x squared, and then the right-hand side becomes 2y plus 2. All right, and then, of course, 2, we can take it to the other side. We are then going to have x squared minus 2 is equal to 2y. And then if we divide both sides by 2, okay, we are going to have y is equal to x squared minus 2 over 2. But if we are to rewrite that, splitting the terms, that should be y is equal to half x squared minus 2, because this 2 is a common denominator of x squared and negative 2. So then we end up with that. Okay, sorry, this part here, it should be negative 1, because we're saying x squared divided by 2, we get that. Okay, half x squared, and then negative 2 divided by 2, we are going to get negative 1. So this is the expression that we are going to have. So then we can then denote our inverse function using the denotation there, half x squared minus 1. That is the expression for the inverse function. All right. And then the second part of the question is state its domain. So we're talking about now the domain of the inverse function there. Now it's important to remember here that for f of x and its inverse, the domain of that function, the range of the function, the domain of the inverse function, the range. How are these related? The domain of the function becomes the range, okay, of the inverse function. And then the range of the function becomes the domain of the inverse function. Now, so since we need here to get the domain of the inverse function, we first of all need to find the range of the original function. So going back to where we were, going back to the original function, there is our original function, f of x is equal to square root of 2x plus 2 for x is greater than or equal to -1. All right. It's easier to get the range of a function by looking at the graph. A quick sketch of the graph would be, we would have something like this. Okay, the domain is starting from -1, and we know that the graph will always go like that. Okay, so that's what we are having here. That is the function. So the domain starts from -1 coming this side. But so if x is equal to 0, because here of course at the origin we have 0 there, x is equal to 0. So if we substitute x is equal to 0 in that function, we get y is equal to 2. Y is equal to square root of 2. That's what we are going to have. Okay. So that's the function. But of course, as you can see, the range, we are looking at this part here. Starts from there. These are the possible values of y. So the range of the function is actually y is greater than or equal to what? 0. So meaning to say that the domain of the inverse function, it should be the domain, it should be x is an element of all real values, but x should be greater than or equal to 0, because that's what we are having here. The range of this, of the original function, we are saying it's y is greater than or equal to 0. So since we are not talking about the domain, we have to use x, not y. So it's x is greater than or equal to 0. So that is the domain of the inverse function. Now moving on to part C of the question. What are we having here? We are saying for the value of k found in part A, sketch the graphs of y is equal to f of x and y is equal to the inverse. Now on the diagram below. Okay, so and what are they emphasizing? They are saying we should label the graphs and of course indicate the intercepts of each graph with the coordinate axis. We have already, when we were trying to look at the first part there, the domain, we already saw the kind of graph that we should expect. Remember the graph of an inverse function. If the basic one, if you have y is and y-axis there and x-axis, the graph of y is equal to square root of x. The basic graph is actually looking like that. Okay, where this is 1. And of course, the y-axis there becoming the what? The asymptote of the graph. But of course, you can see that this graph, if you are having y is equal to, if you are now having y is equal to square root of 2x plus 2. How is graph going to look like? And remember, the domain was actually starting from x is equal to -1. So this is where we are. We have to start from. So this graph was actually shifted this way. Okay. So the graph of y is equal to square root of 2x plus 2, it should be a graph that goes like that, where this part here is negative what? -2. All right. And here, of course, that's square root of 2. All right. That is actually what we are having. Let me extend the graph going like that. So this here is for f of x. That is y is equal to f of x. Now, since the two graphs, the graph of y is equal to f of x and the graph of y is equal to the inverse, the two are actually a reflection of each other in the line y is equal to f of x. Y is equal to x rather. That is y is equal to x here. So meaning to say that this x coordinate, x is equal to, no, sorry, this is supposed to be -1. My bad. This is supposed to be -1. So that x coordinate where x is equal to -1, that becomes y is equal to -1. That's what we need to have. And then for y is equal to square root of 2, that then becomes what? X is equal to square root of 2. Okay, let me erase here. It should be somewhere here. Square root of 2. Okay, so then the graph comes like that. All right, the two, this one and that one, they should be they are a reflection of each other in the line y is equal to x. So now the one in blue, in black there, this is y is equal to the inverse of f. Okay, so that's basically what we need to have here. Remember, function and its inverse, the domain becomes the range and the range becomes the domain. That's the reason why here, for when x is equal to -1 for f of x, we now have y is equal to -1 for inverse of f. And the same also for y is equal to square root of 2 for the inverse, that then becomes x is equal to square root of 2. There's an interchange of variables. So that is what that's the trick. So you only need to know the graph of this one here, and then the other one is just a reflection. Of course, you need to draw the other line, the line of reflection there, which is y is equal to x in this case. Okay. Now moving on to the last part of the question, we are saying find the value of the derivative of f of 7. So what we need to do there is to find, first of all, the derivative of f, and then of course we substitute 7. Remember, our f of x in this case, it is equal to square root of 2x plus 2. This notation here is for differentiation. So I need to differentiate this function. Now I want you to realize that here, this function here, it's in the form of ax plus b to the power of n. That's a composite function. It's not a simple function. So it's a compound function that if we are to differentiate it, we have to apply chain rule. So of which in this case, if we are looking at that general function, the derivative of that is inner derivative. The inner derivative, there is our inner function. So if we differentiate it, we're gonna get a, all right, multiplied by the outer derivative. That's now the differentiation of the whole bracket. We're gonna have n in brackets ax plus b to the power of n minus 1. All right. So applying this in that there, what are we going to have? So we are saying the derivative of that, our inner function, okay, maybe first of all we need to rewrite it. We need to rewrite this function here so that it can be in the form that we have there, this form here. So we are going to have f of x is equal to 2x plus 2 to the power of half. So then we differentiate using that notation there. Our inner function is 2x plus 2. So if we differentiate that, we are going to get 2. Multiply by the outer derivative, where we are differentiating the whole bracket. We're going to have half, in brackets 2x plus 2 to the power of negative half. Now, if we simplify this, 2 times half, we are going to get 1. So we are only remaining with the bracket, which is to the power of negative half there. So we're going to have 2x plus 2 to the power of negative half. Of course, if we write that in simple form, where we have this positive power, we are going to have 1 over 2x plus 2 to the power of half, which of course is the same as 1 over square root of 2x plus 2. But now we want the derivative of f of 7. So in other words, we are substituting 7 in the function. We are going to have 1 over square root of 2 times 7 plus 2. That will give us what? 1 over 4. So that's what we are having here. And that's quite easy. All right. Now, that was actually the last part of the paper. And I hope that if you go through the video that we have for this paper, that should actually help you to prepare for the exams. Okay, thank you.